So, good morning again, everyone. My name is Ericsson. I have worked at Visual Components for almost 13 years now in different roles. The first 7 years in technical roles in Finland and Germany, and now the last 6 years as a sales manager in Sweden. And I'm basically managing the whole of Scandinavia, so Sweden, Norway, Denmark, and Iceland. And with me today, I have Anders Jönsson from Shape Process. What do you do over there, Anders?
Yeah, good morning, everyone, and thank you, Christer. I'm Anders Jönsson from Shape Process Automation, and I work as Vice President of Automation. And what does that really mean? I'm working with technology and innovation, how we should work now and in the future. So I'm really happy to join this webinar and to be able to share some experiences and discuss stuff with you, Christer.
Cool. I think this will be really interesting. So our vision, so mine and Anders' vision for this webinar is that we should have as little text as possible. Now already on the first slide, I see there is actually quite a lot of text, or from my point of view, a lot of text, but there won't be too much text. It will be mostly us talking and showing real world examples. So why did I choose this video for the opening? So for those of you who don't really know Visual Components, one of the true powers with the software and the platform is our extensive library of components. And what we can see from the statistics here on the top right corner, we have almost 4,000 components. I think we are actually over 4,000 now since I made this slide. We have something around 2,300 different robots. And that means that you have a massive library of components to start with before you might have access to CAD data, or when it's too early to actually spend time on making the specific models for your concepts. You can basically just drag and drop, plug and play, and get started. But let's jump into the topic. So basically, we were thinking here that I will start with showing an animation file, actually. So this is now an animation made in Visual Components and exported as an animation file, and it's running now inside the Visual Components Experience app. So what you see in front of you now is an animation that is running, and I can move around and zoom and so on. And this is a powerful way to communicate what you have done with your customers or the internal stakeholders, the people that holds the money for the project, so you can get the funds that you need to realize what you think should be done. And this specific case was somewhere in Czech Republic, right, Anders?
Yeah, somewhere. Yeah.
This was the beginning of our journey together. So Anders just gave me this CAD data of this machine hall, and then told me that, hey, the prospect wants to check how many laser cutting machines they would need, how the flow could look like, and so on. Can you help me with that? So I thought, yeah, why not? So basically started to make a simulation model out of it. And for you in the call that are familiar with Visual Components, you can see directly that this is based on process modeling when you look at these small arrows and dots and so on. And in this model, then Anders and his team could study what the consequences could be if you set up a system in this way. How would the flow be? What would be the throughput, the cycle times? Where should the robots be positioned, and so on? And I guess normally inside these laser machines, you would have one or two robots.
Yep.
So that is something that was not interesting to simulate in this case, because Anders' team, they know very well what's going on inside of this box, but more or less what's going on outside of the box is the interesting thing. Yeah, I think this is a good start for this. Should we head over to our PowerPoint? And
just a comment. Small comment on this one, and you mentioned it slightly. I mean, our expertise are in those boxes or cells, and we have been doing simulations for decades. We're quite good at it, coming from the robotic side mainly. And what was an eye-opener here was to include the full material flow. And that was really important in the discussions with this customer, to be able to easily explain, okay, it could look like this, not only focusing on our small boxes, showing the complete picture. And that was like a mind shift that started this journey, I would say.
Did the customer make more informed questions than he or she would have done earlier?
Yeah, it comes automatically. We'll come back to that later. It comes automatically when they but couldn't it be like this? Can we move it like this? What about rejects? How do we handle that? All those important questions comes directly. And I can just comment also that there was no, we did not sell this layout to the customer, but it doesn't matter. It was eye-opener. It gave us some trust together with the company that we worked with. So yeah, really, really good anyhow, even if it was no sales done.
I think it's quite common that the customer end user don't really know what they want until you show something. And then when you show something, then you can get the dialogue going.
Yeah.
Okay, so October 2023, what happened then, Anders?
Yeah, it was 1 month after your first task for us. We had another one. We started thinking more. Okay, how can we extend our communication with the customer, understand, and we started looking at the case that we had those days, which we made in Robot Studio, which is our base software for robot simulations or whatever, for ABB at least. So we compared. We said, why not compare? What can we do in Visual Components and compare to how we work in Robot Studio traditionally? And then we got a really nice help from you, Christer, since we did not know the software really, showing that we can, I have to say, in crazy fast, get a concept up like this, including picking all products, putting them into the racks, changing the racks, the truck comes and leaves everything. And even though the question was only like to check the buffer on the conveyor, it gave us so much more information. And it was done in 4 hours from your side, which I think that was like for us a trigger to really start thinking, oh, is this really possible? Yes, it was. And then we started thinking, how can we use this in a way to explore a new business? So from this simulation and on, I have to say it was like more thinking about how to implement this, how to start than if. Before it was like, should we really do stuff like this? But after this, at least I was convinced this is the way we need to go to be able to get better systems up and running. So, and this simulation is excellent because it shows what you can do in such a quick time. And then you can keep this if you want to study the robot motion in more detail.
And this, what we see right now on the video, that is interesting. When we have the changeover from the pallets, what happens with the flow on the conveyor line, how that affects. And we get this kind of interesting movements when the belt starts after each other. Yeah,
and the good thing here is that we can run. Normally, what we did before was using those like extreme conditions, reaching to the maximum. Can we stuff like that? What's the maximum cycle time? But that's not fair. Because, you know, when you put stuff in a rack, you get shorter times when you start putting stuff in the nearer position. So getting this more holistic, complete view of what's going on is like crucial.
And I guess also that you could get the correct robot model and didn't need to fake another brand yellow.
Yeah, but now I have seen, after this, I realized, I think Porsche are painting the ABB robots in more or less that color. so it could be ABB. Yeah. But also that's something we started asking you about. How does this work? Can we change the robot? How does that work? What do we need to change? This was a really good starting point, a good case to start at. I
remember one of the trickiest things was the picking position for the robot and getting that cycle time, because you had a clear demand of what the cycle time should be. that was kind of a tricky thing to move the robot and still like not wasting too much time.
Yeah.
So having those blended motions, for example.
Yeah. So this was good for us internally and also for the customer communication.
Feel free to change slide whenever you want now, Anders.
I'm trying.
I'm just looking at the time like, oh shit.
Yeah. So we can talk forever about every simulation here, of course. And this was like a funny one because the demo was made by you in the autumn. And then we thought a little bit, did some benchmarks to other software, and then we bought our first licenses in May. I think 2024 it was, yes, in spring. And then we thought we were, as always, when you're new to something, okay, now we can do everything. And it was so easy because Krista showed us. So let's do a crazy as a packaging line with a lot of components coming together, being in sub-assemblies and material handling and humans in the loop. And there's a truck coming and robots on linear motion and so I think this it's like when we discussed this, like if you're renovating a house or if you're buying an old house, you have no clue what you're starting, and then when you're in it, you just have to solve it. And to be fair here, it's crazy that we managed a lot of support from you in parts how to do it, but in general we managed ourselves to build this system.
I think the last time I supported you on this layout, it was 2 robots, maybe 3. So I have never seen the scope what you were able to do here. It looks amazing. But I guess if I ask you, would you do it again? You would say no on this one.
This is like, I can't imagine how we managed. We have some good guys here that are competent. So we have to move on to let's see if I can click to the next one, maybe. Yeah. So that was a cool simulation, and then we thought about, okay, can we use this for? We already thought about it. How can we use this for marketing? The other you saw was more for like showing concept for customer, reachability and stuff like that. This is more for marketing, showing something that we know this will never exist. But this is a production line for something for automotive. And what we want to show here is like giving the full picture of how a customer's process. And our core business is the water cutting box, so to say. And we want to show to potential customers that, okay, this is how a full production line, fully automated, because we also have that competence in our company, not only water cutting, to handle the product from start till the end, including quality inspection, maybe some extra processes like gluing or other stuff. So this was one of the first, I would say, simulation models which had the purpose of being used for marketing. So it was coming as a request from the sales department. Can't we show something around our water cutting business and combine it with our competence in material handling? So this is, I think this is also nice because it's, for those who have not used Vision Component, it's not only push a button to get this, but it's fairly easy to come to something that looks visually attractive.
I would say what you have done here, which kind of takes you apart from the everyday user, is also camera motions and things like this. So that is what making this look really nice. The camera is moving a little bit, stand still. We instead watch the thing move on the screen, but not the camera moving. It's like an old Disney movie, you know, the characters are moving, but not the camera. And I think that is making this look very impressive. Yeah. The CAD data, of course, also makes it stand out. But the nice thing here is also the blend of your data and the stuff coming directly from the library.
Exactly. So this is a combination of our CAD stuff and standard stuff like how to say, safety guards and linear motion stuff. Just showing the concept. So yeah.
And is this gripper made with the gripper add-on you will talk about later, but the suction cups are replaced?
I will guess like 95%. It's one of those nice features that we are really loving, which makes it like showing concept really easy. It's without spending hours. So yeah.
You can even see the cable there on the robot, for example, looks very nice.
Yeah, and some shadows and some. So it's a good way to. Of course, in the reality, the customer has a factory, a site, and you can't make the line like this fit directly into the customer. But I will come back to that in another when we. But this purpose, showing a concept, getting this discussion started with the customer for marketing. So let's see if I can. Yeah, and then we internally made some education videos or information videos about what you can do easily inside visual components. So here I have two stuff running in parallel, just to show you that we are making those videos ourselves, like how to create this gripper that you talked about, Christer, is on the right video. Then you just work in a few minutes. You have a gripper which is like looks okay and will handle the product in a quite good way, I would say. So you can start looking at cycle time, reachability, discuss the gripper. You can extract the points, contact points from the CAD data to build the real gripper and stuff like that. So within some minutes, you have a end of arm tool connected to your robot. And to the left, we just demonstrated also internally for people that with the right click, you can change the robot. If you started the concept, testing with one robot, and then, okay, this customer doesn't want a FANUC, they want a Yaskawa or ABB or whatever. Cool feature is like easy change of robot. And it doesn't have to be between the brands, of course. More normal is like we switch between the types within a brand, testing reachability, discussing with the customer, moving some stuff, and yeah. So
and here on the other video now we see the creation of the suction cups, which is really interesting. Yeah, it is using some of the kind of built-in tools and visual components to figure out how the surface looks like. And is then able to find that surface and create the suction cups out from the normal there.
Really yeah, so we have a couple of people working with visual components, and when I see this now, then because this we did quite early, we got 2 days of education. That's it. And that
you still have 1 day left.
Yeah,
right?
We still have 1 day. We had to figure out what we need to learn. That's it's too easy to use the software. Yeah. So this was just a deep dive into how you model the effect, how effective it could be, and of course also the sun has its spots. Even though some stuff is super easy, you will always run into or quite often actually run into where, okay, I can't do this with the standard stuff. Okay, this doesn't work as intended and stuff like that. And then you have this emergency exit, Python scripting, which saves you. A lot of pain, a lot of tears sometimes, but there's like this base feeling like, okay, it could be painful, it could take time, but we will always be able to do what we need to do. So that's also something to could think about.
I guess you haven't reached the end of Python yet. You haven't needed to go to .NET API at least.
Not yet. That's so. This is one case we did for showing. This was for a special machine or oven or whatever it is, where we want to put those bottles on this special conveyor And there we got help from you, Christer, again, with like how to conceptually think about modeling something like this. So it's based on the standard, but extended or modified, I could say. Not much, but slightly. And then in the end, it gives a really nice presentation where the customer can see their machine exactly how it would look like. So they understand immediately how this would work. And the modeling was done to check, can we handle the capacity of this system with those robots? So
I think the gripper is really nice with that red detail there on the gripper, for example, makes it stand out. And the motors on top of the, is it a cleaner or oven? It's heating.
Yeah, it's heating. It's heating. So this is a good example. Also, as you said, with the gripper, we have mainly, I would say, 2 persons working with visual components, and maybe it was luck or maybe it was a strategy or both. We have one person coming from robotic programming, a robot offline programmer with a lot of knowledge about that. And then we have another person which comes from the CAD design side. So therefore we can have like super cool grippers, nice layouts, but we also have a really nice understanding of the robot's behavior and what we should do there. So
but then you also have you who have understanding of code.
Yeah.
Or a willingness to understand.
I'm interested in that. Yes. I know some. I usually say I know a little bit about a lot of stuff. So I think we are a good team here, and that made it possible, and also an interest in moving forward, developing how we work, and going further, supporting our business. So I think this is
one detail in this layout which maybe is overseen. Is on the right-hand side on the conveyor, the input. You can see that the spacing between the bottles are exactly the same. Mm-hmm. But on the output, the spacing actually varies quite a lot depending on the cycle time of the robot reaching the furthest away bottles or the closest ones.
Exactly.
And this is something which maybe you don't really think about or foresee. If we look now, there is this big gap over here, for example, and then we have small building the gaps longer. And that could impact the process downstream, that you need to have some bladder stopper stopping it and so on.
Exactly, and it's exactly those things you don't want to realize after building the system. That's we did not do it in this case because maybe it was not necessary or relevant, but often we modify the input stream as well. Like having a random or small deviations in the input to stress test the system. How much can we accept or handle? So that's super important. And we're going more and more now into Monte Carlo simulations and in that direction, really trying, because that's where we will end up in a couple of years or 1 year maybe, understanding a even more realistic process, not only like ideal conditions or worst case scenarios.
There we have this new component actually in ECAD also, which maybe you guys haven't seen yet, that is called Scenario Runner. And that will basically allow you to run many tests. So as long as you have a variable with a number, or actually the variable could be strings also, but then it should be defined. Don't need to be defined either. Okay, you have any variable that does something, then you can add that to a test run. And so, but we did one test that took too much time. For example, if you want to have 3 different inputs, and you want to test them, system will kind of match those together. So when I had 3 different variables with quite many combinations, it wanted to run over 1,000 runs to go through those. So I guess testing with 2 variables, or if you want to have more variables, you should limit the amount of different values those variables can have.
Yeah, that's where we will move, understanding how and to create value from those kind of scenario simulations, because it could explode. And I think we need to move to the next in order to give some space in the end because that's where I really want to have some questions in the end. If people are curious.
So we are now at 9:26. So I don't know if we're in good time or bad time, but we are at least 20 minutes to questions.
Yeah. So this is another. It's rendered. So what you see is the output from a rendered movie. But the whole idea about this simulation is to show potential. It was made for a specific visit at the customer site in Europe in automotive to show. Okay, this is how the product flow could look like. The robot picks the product from the rack up left corner, moves it into the box, cuts some features, and you see on the right there's a handling robot on a conveyor that handles that material flow on the right-hand side, put into the box, and it comes out again. And that's also including like fixture change, it's including quality inspection, and the racks and the products are rather close to what the customer uses. And this is made in process modeling. So in principle, you could like start now, okay, I don't want to have the rack like this. I want a more linear movement or positioning of the different parts in the layout. So it was made modular, so you can easily change this one. And when I say easily, that's a one, you see the robot motions here. Our colleagues spent some time to get those nice.
Yeah, I can imagine so.
Yeah.
You can see that the track has quite intricate motions, actually.
Yeah. So this is spent some time on that. But if you don't care, if you just want to have a discussion with the customer, like, okay, can we change the material flow like this? And you don't care if the robot motion is like 100% or if it's like not even realistic. If you have another discussion around the system, then you can easily move around things. And get this simulation, and then you just press play again, more or less.
Well, we can see the details. For example, the status lights here on top of the machines. They sometimes change colors from purple to green, I saw. We have these gates in front of the machines, right? Those are just the library component that is colorized, I imagine.
Yeah, and the grippers are made with this tool that we saw before. You see the fixture as well. It's like using a tool, but opposite. Yeah.
Nice. Okay, that I didn't realize. That is beautiful. Yes.
Yeah. So it's like it shows you the concept, and it gives a really nice communication base, I would say. Cycle time also. Can we handle it? And inside, you saw the robots inside. They are connected to Robot Studio in this case. Now we don't show it in this movie, but they can run the real cutting program.
Okay.
So this was used. I don't know if we see. No, we don't see them because we closed the curtain. But they were running. So it started trying also this connectivity possibilities in this simulation. Which I will come back to later.
And in this case, you then did the cutting program in Robot Studio.
Yeah. So those robots are connected, and that was just to more or less to get the cycle time correct. Yeah. Because if you have like 80 features cutting holes, if you differ 0.1, then it sums up to too much difference.
Yeah, for sure. Makes sense to run when you want to get those realistic cycle times. The robot program should run in its own environment. If it is an ABB or KUKA or FANUC or Yaskawa or Universal Robots, doesn't matter. It should run there because only they know the internal workings of their black box, so to speak. So
yeah. So we think we are thinking like, okay, we take the best out of two worlds right now, and what we will end up in the future, I have no clue, but that's how we do it right now, at least. And this is another simulation we did for more or less demo purposes. It's for mix palletizing. And I think this is a cool. We were really pushing the limits here again.
Yeah, this is fantastic.
Asking for a lot from the simulation. Now, when I think about it, I don't know how we managed to solve
Yeah.
this. But you have those pallets, 6 different product types, variants. They are represented with different colors here, so they are easily recognizable. Could be cat food or whatever. Mixing. And then in this simulation, we wanted to show that we are capable of designing and running a full system for a customer, not only delivering a part of this. So we can handle all the input conveyors, depalletizing, handling the empty boxes, how to take care of those. The pickers, we work a lot with pickers, so we experience that one, so we know how to do that. And then also going into the package and output and palletizing as well.
You could say that there are 2 legs, right, for Shape Process. You have food and bev, and then you have automotive. That would be the typical ones, or
and then we have, I don't know if we talk about those legs anymore, but then we have general industry as well. So therefore we cover everything. So I think we could talk about those 3 areas main, and then we are working quite intensively now also to strengthen ourselves in life science. So we have done some projects in life science, and now we are pushing that to explore that potential.
I guess if we come back to this layout, what made it difficult is here that the robot programs are, of course, not let's say manually created. Most of it or everything is automatically generated by process modeling, and that means that for you guys who know something about it, we have many assemblies here, assemblies of assemblies of assemblies of assemblies, and then different assemblies that should be deassembled and put together in another assembly, and that assembly should go to another assembly, and that assembly to a 4th assembly, and so on and so on and so on. So it quite quickly becomes very complicated, but the reward then is that you get all of this basically automatically created for you in the end. So most of the time, I guess, went into defining and understanding the patterns.
Exactly, which makes this, that's why I love this approach, because now we can easily, as soon as we have this conceptual way of describing something like this, it's rather easy to change stuff, to modify it. It's not like fixed robot programming, or it doesn't have to be exactly those numbers of products and things like that. So that's where I see the huge potential, how rapidly we can use something like this to modify it, change the layout, and maybe it's only 4 products and whatever.
Making this layout in another tool, a more traditional tool, if it would be at all possible, it would be a nightmare, I imagine.
And here it's also, we have this. It's so easy to manipulate. You realize something. Okay, we need to move this conveyor. Then you can drag and drop. You can. Now it sounds like everything is easy, but I think I mentioned sometimes you run into.
It's always easy when you know what to do. That's the first time when you don't know anything, then everything is difficult.
For example, here, when you use these pickers, those days the performance was an issue. We got some inaccuracies, and we had to work on that to solve the how we handle because it's a fast motion. And it's like, if you look at it's like thousands and thousands of products moving around in this simulation. So it's a kind of heavy simulation for the computer. So
it will be interesting to see how this layout will run in Vision Components 5.0 actually. Should be many times faster.
So here again, we tried this one. We needed some support from you, how to split up assemblies and then how. So, but not too much. We made most of it ourselves, I would say.
It was kind of in the beginning again of this concept. You needed some kick in the butt, basically, in one or the other direction, right?
Let's see if we can. move. This is another. Yes, showing that we can put it inside a building. That was fun. It was just for fun.
And having trees also.
Yeah, trees and whatever. And this is also a nice concept showing one of our more or less standard products to the right, how to palletize and depalletize stuff. And then there was a special process to the left. So it was just
nice cans.
Yeah.
Really
yeah.
good.
That's so. It's also. I would not say trivial, but it was good for us. This was made for customer discussions, but also internally. Okay, how will this work? You see, it's not perfect, but it shows conceptually what will go on. And can we manage the cycle times? Are the conveyors long enough? Where will they be buffers? And also like sometimes the robot, the palletizing, depalletizing, as in the case before, is closer, faster cycle times, and suddenly it's slower. Suddenly we need to change the pallets, and yeah. So I think this is also a nice example how we use it quite a lot.
I see there are technically many things that are challenging in this layout, and one thing that normally allures people is the multi-pick, which I think you have here. You have set in the transport controller where you can say that you can pick more than one item, because I see that the kind of one layer of cans are 2 items, right?
Yeah.
Picking both of them and then place one there, place one there.
Yeah. So, and the building is our facilities here in Karlshamn, by the way. So we just thought it was
new buildings, right?
Yeah, new buildings.
So drawings are still somewhat accurate for a while longer.
I would say, yeah. So that's a cool simulation, or valuable. Let's put it like that instead.
I really like it.
And this is a nice. Also, we have. This is more like showing how it could look like in real, because a lot of stuff you saw right now is like, okay, the full system, the full product flow, sometimes rendered movies. But often what we start with is like looking at the part of a system that we think is crucial for performance or cycle time or reachability of the robots and stuff like that. So this is how we usually start in the visual component, just with some standard conveyors. And this is standard milk from visual components, because it doesn't matter. You see the pusher goes through the buttons. We don't care because the intention was not to have a pusher like that. The pusher would move like that, go up, back, down, and so.
Yeah, it would do this kind of motion, right?
Yeah, but in the concept phase, trying to understand, trying to discuss with the customer, this is excellent. Then we can quickly create something. It has been really useful where we have like high production flows like this, because suddenly you realize, okay, because if you see it on a paper, on an Excel sheet, 14,000 bottles per hour. For me, I can't grasp it.
Yeah.
I don't understand, to be honest. Okay, it's a lot, but how much is it? And then as soon as we put that product flow from a product creator and onto a conveyor, then you realize, okay, now this is crazy. Now we have to start thinking. So just showing the product flow is also like, would be valuable enough sometimes.
Yeah.
That's and it's nice to try concepts. And what we did then, and did I stop the?
Yes.
Yeah. So this is the full system then, and that what you saw was on the top level, just a part of it, and this is how it looks like in reality. 3 stations that we're building, connected with conveyors and spiral conveyors, and a full handling of from product to palletizing. Different products, different crates and stuff like that. So since this is also even on 2 levels in the factory, understanding the product flow, understanding what will happen, the amount of products or crates or pallets needed.
I saw, for example, the crates were accelerating there to create a gap for the sensors, right?
Yeah, yeah.
Just that detail.
Yeah. So here you can see the full simulation that we ended up in, and what I don't show here is like in the beginning you show this viewer of the first simulation we ever did with you, and that's something we're using here as well to show the different product variants, the palletizing patterns for our PLC programmers, so that everyone knows internally, okay, this is what we should do. This is the other, so we can run that viewer for different products, and they can easily go back and forward to understand how they should program the system.
This view is one of my favorite renders I've ever seen from Visual Components, actually, what we're looking at right now. It looks amazing.
And it's a big shootout to Jimmy Hansson, our rendering guru, I have to say. He's really into he makes excellent stuff. Excellent.
It's amazing. There are so many things, but for example, that little detail with that the crates are accelerating there onto the second belt. That must be to create this gap for the sensoring.
Yes. So we can do that, and we can check some stuff here. So it's There are some glitches in the rendering, which I will not mention for you, so then you don't see it. That's it. But this is cool. It's cool, but also high value. I don't. Normally, it goes together somehow for me. That's and this is used now from the concept phase. It was used for showing the full system. It was used as an input for the automation team how to program it. And I will now show you another case where we want to take it even further. We still have
now we are 9:42, just so we know. So I guess we will have a little bit less time for questions.
Yeah. Why can't I change now?
I can try it. Let's see. Oh, there.
Yeah. So this is for life science. Also, now we come back to marketing again. So the previous video was really for from concept sales to the project, and this is more for marketing, showing some old projects we have done, some concepts we have in our pocket that we could implement at the customer. So if we go to a sales show or trade show, we use this movie as a marketing thing. Also, I think we publish something like this on LinkedIn and stuff like that. So we use it also now quite a lot for marketing, I would say. So we can show a lot of cool processes. It looks good. It looks realistic. It connects the customer to us. It gives some kind of trust. They can feel connected. Okay, this looks similar to our process or whatever, our product. So it's made communication much easier. It's and this is another for kind of life science, handling those plastic stuff going into cleaning device. You don't see all things going on here, but then putting them out again. So here we can show and this is also something that we have got a lot of attraction for. Just simple setup.
So this doesn't take many seconds to make in Visual Components, but that looks very impressive.
Yeah.
Very impressive.
So it's kind of cool as well. I think we just skip the rest of this one and move to the final usage, not the final usage, but latest one, where we are exploring connectivity. That's where we connect the simulation with the right, it's in Swedish, the right PLC code with the right HMI with the original functions. So we're running the PLC, we're running the HMI using PSSIM Advanced and the HMI simulator, I don't remember the name, connected to the Visual Components. And in Visual Components, in this case, we also included physics. We did not talk about that before, but in this case, this system is, I would say, impossible to program. We don't want to program the simulation since the PLC is already handling it. So here the boxes are just dumb boxes being pushed and handled by the PLC. So the simulation is handling most of the stuff that goes on in simulation. So it's a palletizing system that we're doing. And the robot motion, you can see on the right movie, is running in MotoSim. So it's at Yaskawa. So we connect Yaskawa MotoSim, running the real robot jobs there, running the real PLC, and in the middle is the simulation. And why did we do this? It's a good, fair question. If we had the PLC already and everything, so it's actually on creating new palletizing patterns for an existing system without disrupting the company that runs the system. So this is located in Germany. We don't want to go there, stop their production doing tests. So instead we sit here in Sweden, Karlshamn, create the full PLC and robot changes that are required. Mainly it's a recipe change for the new product. Test it, validate it, and then we just send it to the customer. And then, of course, it will be some adaptations necessary.
Mm.
So this is where I see we need to move further in the future.
Do you remember what you told me about the LEDs there on the gripper, for example?
Yeah. There are some stuff which are easily done in the simulation environment, which are difficult. Like the programmers, they wanted to know, did they program the correct vacuum zones on the gripper? And it's really hard to see in reality. You have to okay, you see it if you lift the box, of course, but otherwise you would see it in advance. And here we just added some light indicators, LEDs on the model, so the programmer can easily see, am I positioned correctly? Do I engage or activate the correct vacuum zones? Do I get the correct number of boxes in place and stuff like that? So
there we see them on the left side, or so.
Yeah, I think that will come again soon.
Yeah.
So this is why, and the feedback from the people that uses this is quite good internally. And the final one, time is running away, Christer.
Yeah.
Thanks for switching.
This
is just to
show you. I didn't actually switch it.
You didn't?
No, I don't know. I thought you changed it in the middle of your sentence. Okay.
Maybe it was a perfect switch. Anyhow, so this is just showing where are we now in terms of what we are simulating. So this is you see to the right are water cutting boxes, kind of modified standard boxes product for us. And this is to show the customer, okay, this is, if you buy those three, how will it look like around it? Will we be able to handle the capacity? How will your factory look like? So we, I don't say play around, but we explored also some other cool features which are standard in Vision components. So I think this is also an excellent way of how we can easily expand our business, I'd say, to show more, that we can do more than just what we have already done in this. And in this case, again, rendered to give a nice look and feel to it. But in the base, it's a simulation which has the highest value. So yeah, this is also where we are right now, I would say. We are working in complex simulation flows like this. We're working with connectivity stuff, and we are working with speed, how fast we are. 1 year ago, we made maybe one normal simulation model, took us 1 to 2 weeks to make 1 year ago. And now our team are producing, I would say, 2 to 3 simulation concepts average per week instead. So we have hundreds of simulation concepts done at different levels, from this super advanced or holistic to small studies. So we really accelerated the performance of doing simulations. So we are looking forward to continue this, and
creates this positive spiral, right? You can do more with less time, and you get better results out of that less time that you actually are spending. And maybe you're then also, so you can answer more RFQs. You can answer them faster. You can answer them with better position, and you can then hopefully also win more of them.
Yeah. So I would say we are on this, this Gartner hype cycle where everything is we are quite high up right now. So the problem with that is that you want to, and the organization wants to simulate everything because it's a high value, cool, and now we are struggling, or no, not struggling, discussing, and we need to move forward also. How do we decide? How are we more specific of what do we want from a simulation? What input do we need?
KPIs for a simulation.
The KPIs, exactly. Yeah. What do we want to get out of it, really? What's the purpose?
Cool stuff.
That's cool stuff. Could be, because we are limited in resources, even if we are fast. So we need to understand, okay, maybe this should not be simulated. Maybe we don't need an advanced rendered simulation of a reachability study, maybe. Stuff like that.
Yeah. So how are we looking on the slides? Are we soon?
Yeah, we are soon done, but I guess we could... can you move I think we open up for questions, because I think I talked about this
one.
It's too much text. Just skip it.
Too much text. Yes. Yeah. Okay. Let's go to the main text slide.
Yeah. We are already over time. So.
Yeah. So then let's think, how would we do it with the questions now? Because I guess I need to stop sharing the screen for me to be able to see the questions. So I will stop sharing the screen. And then I will go to questions, and let's see. I will read it, and you can answer, or I, depending on what it is about. So we have from Alexander Fassel, great presentation of the VC features. Thanks a lot. How is it possible to render videos in that stunning visual quality? For pictures, I already used the Blender plugin. Is it also possible for videos?
Yeah. Should I answer? Because you want to answer, but I will answer.
Yes, you go ahead.
We are using Blender as a tool, and I don't know exactly the details, but for some features and depending on the level you want to reach, our team here do some hands-on also inside Blender. So if you just want to render, you can do it with a click. But if you want to have let's move the lights a little bit more, let's have some better textures. If you want to work on it, if you the focus of the camera and things like that.
Yes, exactly.
Then you need to move into Blender, so that's how we work with. So it's the milk stuff is in Blender.
A lot of nice tutorials on YouTube for Blender. So I also do exactly what Anders said. Like if we look at my picture here, I would do 95% of Visual Components. Everything that is good in Visual Components, I do in Visual Components. All the motions, everything like that. But what we are not specifically good at is lights. So we are not very good at lights. We haven't focused on that. So lights are just better in Blender. So I would create them quite often in Visual Components and move them around and test intensity and things like this in Blender to reach where I want to reach.
Yeah, I think camera animations, I think, and camera control in general is you get more advanced features or full control inside Blender.
Correcto. So that depends kind of how much time do you have and what you actually want to gain out of it. Many times it's enough with the default, but if you want to go the extra mile, you should do the last step in Blender, I would say. Okay, next question seems to be for me. Is it normal to have access to this level of support during layout creation? I know it was not so much, but the small tips and guidance can make a huge difference in the final result. Thanks, Harry. So I guess it is not that common to have it, but here in Scandinavia, I mean, I am my own boss. I decide where I want to spend the time, and for example, with Anders and his team and the other system integrators in Sweden, I have quite often communication with them to see that they get where they want to go.
And I can also say that we have also learned, at least my impression, when and what to ask for.
Yes.
Not just can you do this layout for us?
Exactly. So you would never ask that. It is more that we are stuck here and we're all crying, and we want to stop crying.
Yeah. I usually say using Visual Components is like riding a roller coaster. You
Yeah,
feel like
yeah.
really happy and sometimes less happy.
Excellent.
But still, it's a ride. Yeah.
So another question from Harry here. Hi, Anders. You mentioned you had a team of 3, including yourselves, working with visual components. To achieve these fantastic results, how much time in the working day was your team dedicated to creating these visual components layouts? It asked, was the CAD design robotics specialist have this as the main project, or did they do this while juggling other major responsibilities?
Yeah, good question and super hard to answer. But what happened was also like we made an organizational change during this period we have discussed. So now we have a dedicated proposal team. And those 2 resources that are working with visual components are now in the proposal team. So that's where they are located. Mainly working in visual components, I would say, as the daily tool. But like I don't know how many hours they put into it per day. Sometimes they have to think as well. So I would say maybe one full-time person. I would say in average is spending time in visual, maybe even more now. It's so effective. So quite a lot. So and they're using it as tool to do something. It's not like they are simulation experts. They are like concept proposal engineers.
Concept experts.
Yeah.
We have a comment from Monique at AVB in Denmark. Okay, I will just read it. I'm a big fan of visual components, and true, it gives you a lot of insight in the flow as well. However, it does not give an honest, real cycle time of the robot, since the ABB Robot Studio Virtual Controller is one to with the real controller and the visual components. It's not. So you really need to be careful in case of critical cycle time evaluations. Yes, we are both completely agreeing with you here, Monique. And I think we also touched it a couple of times here that when you have, let's say, if you're interested in is it 9 or 9.4 seconds, for example, visual components will not give you the right answer there typically. And the faster application you are running, the faster moves, the more off likely we will be in cycle time. So if we are critical on the cycle time aspect, I would always recommend my customers to run the robot code in the native controller. But that doesn't mean that you need to create the robot code in Robot Studio. You could create it in Visual Components or any other way, but if it is time critical, you should run it there. So if it is me, or if it is Yaskava, or if it's you or Fanuc or Kuka or whatever it is. Yes. So we both agree with you. Then we have Tobias at SKF. As a turnkey supplier of total automation project, what percentage of overall project time and resources is usually allocated to simulation using Visual Components software? So what percentage of overall project time and resources is usually allocated to simulation?
Good question. I don't know if I should, but I can give an estimate instead. So if we look on more complex simulations, I could think about, let's say, some percentage. Actually, some percentage.
So I guess it could vary from something 0 point something to something.
Yeah, but it's not like 80%.
No,
of course.
No, for sure not.
No. Yeah, so some percentage, I would say, depending on it. Yeah.
So from Vitaly at Yaskava, impressive simulations, most of them done using process modeling, but when the simulation became a physical project, there is no way to reuse any code, so to say, from the simulation, right? Question mark. It is then to be programmed from scratch. Do you usually use proprietary software then, Robot Studio, Motosim, etc., or continue to program in Visual Components and then post-process the code? Thanks.
We normally transition to the brand program environment. Always, I would say, always. The short answer, since time is running out.
Yes, and I guess if you would be making more offline programming, so from a visual component point of view, offline programming meaning welding and things like this, then we would have really nice tools to create those. But for the picking and placing and so on, yeah. Okay, by the way, thank you for a great and interesting presentation. I have one more question. How much time did you personally spend using visual components to create the simulations you presented today?
Me?
I guess it is you.
Yeah, too many nights and weekends. This is a huge interest for me. So I don't have it as a working task normally, or so. But yeah, I don't know. I don't want. I spend quite a few hours. But my goal is to understand the capabilities and exploring the potential. Not the daily work here. Really, that's handled excellent by the team.
I guess this one is more from me, Anders. Is it possible to use models from any CAD software like Fusion 360 or SolidWorks? Yes, we support more or less all the standard CAD softwares. I can link to you also very soon if I just open the correct browser. I will put a link there in a second to the CAD formats that we support. There. Also, do we need to model all the things like robots, conveyors, workers, etc., or is there any pre-made models? Yes, so maybe you missed the first slide of this presentation, but we do have north of 4,000 components that are pre-made in the software. So let's see, we don't need any help for that. We want to go there. If we just run that again. So basically, what you see here is something that you can find directly from the library. Just drag and drop, plug and play, and start to work with. So over 150 different branded components exists in the library. And then a lot of generic stuff.
Yeah.
Okay. Yeah.
How to do this is like to know how to get effective is how to know, and that's what our team is knowing, when to use the standard components, when to modify them, or when we need to create our own stuff. So we have found some clever ways of doing that. So
yeah, I think that's a very good ending statement for this show. I hope that you all enjoyed it. I don't think, did we ever reach the last slide here with the text? Yes, we did, but let's open that here now again, like so. So very high definition picture we got here. Sorry for that, but at least the text down here is in high res. So the idea is that if you have further questions, you can reach out to us directly, or the preferred way is to go through our respective websites, use the contact forms, and somebody from the territory that you are inside will reach out to you. So either if it is a question for a shape process or if it is for visual components, please use the contact forms on the websites.
And a big thank you to you, Christer, and your team for letting us having this webinar together. It was really fun and valuable for us to show also a little bit of self-encouraging to show what we have done.
Awesome, Anders. I'm really happy that you were able to join and that you are actually able to show something what you're doing with visual components, because I know and I have in my head hundreds of cool layouts, but it's so rare that we get to see something. So I'm super happy and excited that you were able to show and share and tell about your journey so far. And let's see where it goes from here. Okay, then thanks all. I will close the webinar. We can stay on this, but I will close the webinar now. Bye for now, guys.
Thank you. Bye.